Welcome to this video on the fundamentals of CV joints and propshafts. We will cover the essentials of these drivetrain components as part of our automotive training series. This video is structured to guide you through the definitions, roles, types, and maintenance of CV joints and propshafts, concluding with real-world case studies and assessment questions. We will examine common failure symptoms, maintenance procedures, and repair protocols to ensure you have a comprehensive understanding of these critical automotive parts. In this introduction, we outline the path to mastering CV joints. This includes identifying components, diagnosing wear, assessing damage, and applying proper documentation standards for claims. The purpose of this manual is to standardize knowledge, improve technician competence, reduce costly misdiagnosis, and support professional training and certification efforts. By the end of this video, you will be able to identify CV joint types, diagnose failure modes, assess claim validity, and ensure accurate claims processing. Next, we explore drivetrain fundamentals, specifically focusing on the roles of CV joints and propshafts, and how different vehicle layouts impact their design. CV joints are essential for transmitting power at constant speeds. They accommodate steering movement, handle suspension travel, enable flexible drivetrain designs, and help reduce noise and vibration for a smoother ride. Propshafts transmit torque over distances, such as from the transmission to the differential. They are built to handle high torque, maintain smooth power delivery, and adapt to vehicle movement through universal joints. Drivetrain layouts, such as front-wheel drive or rear-wheel drive, determine how engine power reaches the wheels. These arrangements influence vehicle handling, performance, and the required drivetrain components. This visual illustrates various drivetrain configurations, highlighting the differences in how power is distributed across the wheels in RWD, FWD, AWD, and 4x4 systems. Moving into our deep dive on CV joints, we will examine their specific types, primary components, common failure symptoms, and the standard procedures for maintenance and replacement. There are several common types of CV joints, including Erzepa, tripod, double offset, cross groove, and Bendix Weiss, as well as distinct inboard and outboard configurations. Each joint serves a purpose. Erzepa joints are common for steering, while tripod and double offset joints are typically used for inner positions to allow for suspension-related plunge movement. As of 2026, the industry heavily relies on Erzepa ball-type and tripod-type joints to meet the demands of modern AWD and electric vehicles for higher torque and greater suspension angles. Let's look closely at the Erzepa CV joint. These joints are widely used for their ability to operate at steep angles while maintaining a constant velocity, making them ideal for outboard wheel end positions. Next is the tripod CV joint. Often utilized in inboard positions, this design uses 3 rollers to accommodate the plunging motion caused by suspension travel, ensuring smooth power transfer. This image provides a technical look at the internal structure of a constant velocity joint, showing the arrangement of balls, cage, and housing that allows for angular movement. When diagnosing issues, remember that failing joints often show warning signs. Clicking or popping noises during turns usually point to a worn outer joint, while torn boots lead to lubricant loss. Other symptoms include vibrations during acceleration, indicating inner joint wear, or even a total loss of power to the wheels in cases of severe internal failure. Maintenance and inspection are critical. Regularly checking the rubber boots for cracks, tears, or grease leakage can prevent dirt from contaminating the joint and causing premature failure. When performing repairs, correct greasing and proper boot installation are essential. Using the right type and quantity of CV joint grease is necessary for long-term component health. Turning our attention to propshafts, we look at their role in connecting the transmission to the differential, ensuring the efficient transfer of power across the vehicle's length. Propshafts rely on center support bearings and universal joints to manage rotation and accommodate changes in the angle between drivetrain components during vehicle operation. Common propshaft issues often involve vibration or clunking sounds, which can stem from worn universal joints, failed center support bearings, or imbalances in the shaft assembly. For warranty claims and diagnostics, accurate documentation is vital. Always photograph damaged boots, document specific noises heard, and note the precise location of any observed grease splatter. We now review case studies to apply what we've learned. Analyzing real-world failures helps in identifying misdiagnoses and improves the accuracy of future repair and warranty assessments. When assessing a claim, verify if the reported failure was caused by mechanical wear or external damage, such as road debris or improper installation, as this determines the validity of the claim. Let's review what we have covered. We examined CV joint and prop shaft fundamentals, identified common failure symptoms, and outlined best practices for maintenance and diagnostics. Thank you for completing this training module. By applying these standards, you contribute to better vehicle reliability and more accurate, professional service outcomes. This final section includes a series of assessment questions to test your knowledge of the materials covered in this video. Question 1. What is the primary function of a constant velocity joint in an automotive drivetrain? Question 2. Which type of CV joint is typically used in the inboard position to allow for plunging motion? Question 3. What is the most common symptom of a failing outer CV joint when the vehicle is turning? Question 4. Why is it critical to inspect the CV boots regularly for cracks or grease leakage? Question 5. What components in a prop shaft assembly are responsible for managing rotation and angular changes? Question 6. What should be included in your documentation when submitting a warranty claim for a drivetrain component? Question 7. How does the drivetrain layout, such as front wheel or rear wheel drive, influence the components used? Question 8. True or false? Improper installation of a CV boot can lead to premature joint failure. Question 9. What type of vibration might indicate wear in the inner CV joint during acceleration? Question 10. Why is accurate diagnosis important for both repair efficiency and warranty claim validity? Take a moment to review your answers against the provided course materials to ensure you have mastered these concepts. If you missed any questions, we recommend revisiting the specific sections of this video to strengthen your understanding. Consistency in applying these technical standards will lead to more reliable repairs and higher customer satisfaction. This concludes our training module on the fundamentals of CV joints and prop shafts.